Hi, I'm Andrea with AWS. We hear a lot from our developer community about serverless and AWS cloud technologies. Here are some interesting ways our customers are architecting serverless solutions. Let's begin with Food Hub and see how they're handling order processing at scale.
Hi, welcome to This Is My Architecture. I'm Jasmine and I have here with me Dinesh Durai from Food Hub. Hi Dinesh, thanks for joining us.
Thank you for hosting me today. We use a lot of Lambda resolvers. So basically for order syncing and notifications, dashboarding. So Lambda resolvers helps us a lot and it helps us during scale as well. And what we also do is based on the Lambda. In the past, we use Aurora as our database. Now we moved into dynamodb. So what dynamodb is gives us a length and breadth of services what it has. And with AWS managed services, it helps us to scale during a peak period.
Okay, great. And I see this is serverless architecture. So how does that help you in scaling as well as reducing your operational overhead?
Okay, so predominantly most of the order placements happens on a weekend, for example. We also do on a weekend, right? On a Friday, say between 5 to 7 is a peak period, right? So where the orders are getting placed by consumers. And same way, the clients, the restaurant owners needs to process those orders fast, right? So with AWS managed services, we could able to scale in breadth and length, and we can able to maintain the concept of speed.
Great. So basically on weekends, you might see spikes, right? And these are not gradual increase of orders, but a spike in particular period, right? And that's where something like DynamoDB helps you, which is a NoSQL database, right? And amazing that this is completely serverless. That's great. Now coming to the insights that the restaurant owners need in terms of any metrics. So how do you take care of that?
Okay, so predominantly what happens in the day, the restaurant owners wants to process the orders. So they want to look at the stats before closing the shop so that they know what they have got and how much they earned and so on and so forth, right? So where insights becomes a key component for them. And what we do is from the DynamoDB streams, we passes the data to the Kinesis, so where it can manage the state. And from Kinesis, we push to S3. So S3 is our data lake at this point, where we store all the data and we run ETLs over it and we start computing the data. So in the end of the day, right, see predominantly all the restaurants closes at 11 p.m. and everybody wants to see the stats, and you can assume the volume. We have around 20,000 plus, 28,000 plus restaurants who might eat at the same time.
Wow.
So thus, we serve it from S3 and we use QuickSight as our predominant dashboarding tool where we could able to see it. Not only the restaurant owners, the internal back office people wants to know how the restaurants is fared today, or probably should I do some campaigns for them. So for all those insights, S3 QuickSight provides us a lot of insight, and we could able to maneuver the data and take data-driven decisions.
That's amazing.
Now let's look at how Freightways is delivering 50 million packages with the serverless tracking solution.
Welcome to This Is My Architecture New Zealand. I'm Andre, and I'm here with Dean from Freightways.
Hi. So an API built in the Fargate service allows us to consume those scans from the different sources and persist them within the DynamoDB. So the driver goes to the Fargate and then stores it in the DynamoDB.
And what made you choose DynamoDB?
It was easy to integrate with. It's performant. I hope copes with the different loads during the day. It's really cost effective, and also allows us to feed on through DynamoDB streams to services downstream that are interested in the scans.
Oh, great to hear that it was a good fit for your use case. So at this point, you have the scans stored. How do you process them after that?
So we have a Lambda that picks it out of the DynamoDB streams. And in fact, then it passes it on to down to SNS, which then fans it out to SQS for processing by other services.
I say. That's an interesting pattern of having SNS with multiple SQS queues. What made you arrive to this solution?
Well, we have lots of different services that are interested in it, so it allows us to iteratively add new features to our stack, such as there's a service that processes all the images that comes through on the scans as well. So that passes off to another Fargate service that does processes images.
I say, so it enables your rapid feature development.
Yes.
How did you start this journey? Did you start it with this, or did you have evolution here?
In fact, we started with Amazon MQ, but that wasn't able to cope with the 1,500 scans per minute. So we were able to pivot fairly easily to SNS and SQS, which is also a software as a service. That was quite attractive as well.
Well, I think that's a great example where you have been able to change the integration of the services when the business needs arise.
Lastly, let's check how Vertex Pharmaceuticals built a serverless molecule search platform.
Hi, welcome to This Is My Architecture. I'm Sudip, this is Roberto from Vertex. Roberto, how are you today?
Well, thanks. There are tens of billions of potential small molecules to evaluate, so our computational chemistry team asked to work with us to create a platform that would let them more intelligently search that space to find molecules to synthesize in the lab.
Excellent. So these are probably maybe non-technical users, right, chemists? So maybe you can talk through how they are interacting with the platform.
Sure. So our chemists have a client that runs on their laptop that allows them to submit a request to an Amazon API Gateway API. They, in that payload, submit a post request with some JSON that includes the type of search they want to run, as well as the size of the fleet of workers they want to create for that search. That request comes to an AWSLambda function that enriches that search with some additional details from a relational database, and then creates this environment on the fly in response to some of those parameters.
Excellent. So actually dynamically creating this environment based on some parameters that were placed by the chemists.
That's right.
Interesting. Okay, great. And I'm noticing, so you've got, you're spinning up Fargate here, which is also spinning up workers, an Elastic Container Service. So maybe you can kind of talk through, how Fargate is spun up and what the worker nodes are actually querying.
Sure. So as I mentioned, the Lambda will spin up this environment based on parameters of the search. That includes the size of a Fargate spot fleet over here on ECS. It spins up one task that essentially drives the search. We call this the orchestrator. So Lambda will spin up the orchestrator, and the orchestrator communicates with the search workers via RabbitMQ on Amazon MQ. So the orchestrator will tell the search workers where to look next. The workers pick up that work and execute the search. And this is actually an intelligent search. So the workers will report back details of how their search is going. That information comes back to the orchestrator, who then further influences the search by telling them where to look next based on what it's hearing back from the
Excellent.
workers.
Wow, so interesting use of MQ there, not just queuing requests, but actually helping you with that intelligent pattern detection.
That's right.
Excellent.
We hope you enjoyed watching how these customers use serverless in their AWS cloud solutions across a broad range of industries. Find out more by watching the full episodes from the links in the description. And keep watching This Is My Architecture.